Here in this problem, whatever data you have to provide, whatever information is given in the problem, the first thing is the cross section of beam is rectangle. The cross section of the beam, which is in a rectangular form, which has two dimensions. One is width and other is depth. Both are given 100 mm by 200 mm. 100 is width and 200 mm is depth. Figure is given as shown in the figure. Calculate the shear stress at 50 mm below the neutral axis. We have to calculate shear force at the 50, which means that shear stress is represented by here Q particularly. Shear stress is also represented by sigma, but another notation for representation of shear stress is Q. Then calculate shear stress at 50 mm means that we have to calculate shear stress at 50 mm from the neutral axis. What is neutral axis? Neutral axis, which means that layer of the beam which neither be elongated nor shortened. Okay, means there will be no effect induced on that layer of the section of the beam, and that layer is said to be neutral axis or neutral layer. Means there will be no effect by the external vertical load that will act on the beam section. That layer is said to be neutral layer. Okay, that layer neither be shortened nor elongated. Okay, and the take shear force is given 70 kilonewton. Okay, that information is provided. Then in this problem we have to calculate shear stress at 50 mm. Okay, then first of all, whatever information you have provided, you can write that information. Here this is a rectangular section, this is a rectangular section, and here this is a width is represented D 100 mm. Then this is a depth is given. What is the value of depth? 200 mm. 200 mm. Okay, that depth is given. Here, this is a neutral layer or neutral axis. This is a neutral axis. Okay, this is neutral axis. Neutral layer or neutral axis, which is passing through the centroid of the section of the beam. Always remember. And we have to calculate a shear stress at 50 mm from the neutral layer. Here, a rectangular section having a rectangular section having whatever data width B is given 100 mm, depth B is given 200 mm. Okay, width is given 100 mm, a depth is given 200 mm. Then shear force F is equal to 70 kilonewton. 70 kilonewton. That means 70 into 10 raised to 3 newton. Next, y distance of layer below the neutral axis. Y is distance of layer below the neutral axis. That distance is 50 mm. To find Q50. Okay. Y, what is the Y? Y is the distance between the neutral axis and extreme layer, most extreme layer particularly. Here, 50 mm from the neutral layer, that layer is given, and distance between the neutral axis and that layer, that will be given 50 mm. Here we have to calculate shear stress at 50 mm. It is represented by notation Q50. Okay. Here, rectangular section having both width and depth is given. Then shear force is also provided. It is represented by capital F, 70 kilonewton, which means that 70 into 10 raised to 3 newton. Then y is the distance of layer below the neutral layer. Neutral axis or neutral layer means that distance y is also considered below the neutral axis to the extreme layer as well as above the neutral axis to the extreme layer. Okay, this is the extreme layer particularly of the section of the beam. That is the top extreme layer, that is the bottom extreme layer, and that is the neutral axis or neutral layer. Okay, and y is also considered below the neutral axis, above the neutral axis. Means y is, that is the distance from neutral axis to layer, that is above or below. Okay, doesn't matter. Means here y is the distance below the neutral axis, that is 50 mm is given. Then to find shear stress at 50. Then if you want to find out the shear stress at 50 mm, it is represented by a particular formula Q50 6m divided by BDQ bracket B square y square. Here the formula for Newton means if you want to calculate shear stress above or below neutral axis, then in that condition or in that case we can use this formula Q50. Suppose that layer distance here 50 is given. In some other example, that is 100 is given, 110 is given, whatever that value, doesn't matter. But if you want to find out a shear stress at particular distance from the neutral axis or neutral layer, in that condition or in that case, we can use only this formula Q distance, that is equal to 6f upon BDQ in bracket d square upon 4 minus y square. Clear? In which condition you can use this formula? If particular distance is given from the neutral axis above or below the neutral axis, and in that condition or in that case only and only you can directly use this formula 6f upon BDQ in bracket d square upon 4 minus y square. Okay. Here a 50 mm distance below the neutral axis. Okay, we have to calculate shear stress at 50 mm below the neutral axis, and you can directly use this formula Q50. Okay, shear stress is represented by Q at 50 mm means Q50, which means that shear stress at a distance 50 mm above or below the neutral layer. Okay, that is equal to 6f upon BDQ into in bracket d square upon 4 minus y square. Then you can put up the value 6 into 70 into 10 raised to 3 divided by d is 100 into d is given 200 cube bracket 200 square divided by 4 minus y is given 50. Y is a distance from neutral layer or neutral axis. Then you can just do the simplification or calculation. Then after calculation, we get final values. That value will be Q50, that is equal to 2.8125 Newton per mm square. That is unit for shear stress. The unit of shear stress is Newton per mm square. Okay. After you just do the calculation, you just do the simplification, and after simplification, we get final value Q50, that is equal to 2.8125 Newton per mm square. Okay, well, that is the value of shear stress at a distance 50 mm below the neutral axis. Okay, this is the very simple way to find out the unknown values of shear stress at a distance 50 mm below the neutral axis. Okay, here only one formula is very important. This formula is very important. 6F Q50 means that distance is varied. Okay. Here in this problem 50 mm is given below or above, doesn't matter, but that distance is varied. Q50 means Q distance, any distance that is above or below the neutral axis, that is equal to 6F upon BD into bracket b square upon 4 minus y square. Okay, that is very important. Then you just put up the value we already provided in the problem, and you just do the calculation, and after the calculation we get final values of the shear stress at a distance 50 mm below the neutral layer of neutral axis. Okay, and then here if you want to draw shear stress distribution diagram, the diagram will be like this. Means here at the extreme layer shear stress will be 0, at the neutral axis shear stress will be max. Okay, this is the very simple way to calculate shear stress distribution. This is a very simple way to draw shear stress distribution diagram. Okay, means in this diagram I will just repeat once again. Whatever data you have provided, whatever information you have given in the problem, then here in this problem diagram is provided, that diagram which is in a rectangular section. Then here a width, the rectangular section having both width and depth is given. The width is 100 mm, it is represented by B, and depth is 200 mm. Then shear force is also provided, that is represented by notation F, that is equal to 70 kilonewton, 70 to 10 raised to 3 Newton. Here Y, the distance of layer below the neutral axis, that is 50 mm, that distance is provided. Neutral axis means this is the neutral axis, and below 50 mm means here below the 50 mm, that distance is 50 mm. Okay, that is represented by Y. This distance, this is Y. Okay, Y that is equal to 50 mm below the neutral layer or neutral axis. Okay, and depth is given 200 mm. Okay, means that rectangular section having depth 200 mm, that is center is 100 mm, where the neutral axis is passing through it. And below the neutral axis that distance is 50 mm is given, and this is said to be layer. Okay, and Y is the distance between the neutral axis and layer, that is bottom layer, bottom layer. That distance is represented by Y, that distance is provided 50 mm. Then in that case we can use only one formula, that is Q distance, that is equal to Q means any distance. Q is the shear stress. If you want to calculate shear stress at particular distance below or above the neutral layer, then in that case you can use this formula Q50, that is equal to 6F upon BDQ into in bracket d square upon 4 minus y square. Okay, that formula is only applicable where we want to calculate shear stress at particular distance from the neutral layer, above or below the neutral layer. Okay, in that case you can use this formula only. Okay. In the same, similarly, in similar way, we can find out more example which is based on that concept or that formula. Then here I will take once again one another example which is similar to previous one. I will read that example. Here, a beam of 1 minute. A beam section 100 mm by 200 mm is subjected to shear force 60 kilonewton. Determine the shear stresses induced on layer at 50 mm above neutral layer and 25 mm below the neutral layer. Means in this problem we calculate shear stress above the neutral axis and below the neutral axis. That distance is provided above or below. Means here shear stress is induced on layer at 50 mm above neutral axis. Means above the neutral axis that distance is provided. Shear stress means Q50 above the neutral layer and 25 mm below the neutral layer means Q25 below the neutral layer. Means here in this problem we have to calculate shear stress at a distance 50 mm and shear stress at a distance 25 mm above or below the neutral layer. Here, whatever data you have provided, section is provided. That section is a rectangular section. Okay, that is rectangular section having a depth and width is provided. Depth is represented by notation d, small d, and width is represented by notation small b. The rectangular section is given. Then other thing is given, that is shear force, means it is represented by notation F. 60 kilonewton, 60 kilonewton means 60 into 10 raised to 3 newton. Determine shear stresses induced on layer at 50 mm above the neutral axis. Means shear stress is represented by notation Q, small q, 50 means Q50. Okay, what is meaning of that Q50? Q50, which means that shear stress induced on layer at 50 mm above the neutral axis, above or below doesn't matter. Okay, means that distance is considered from the neutral layer. Okay, and 25 mm that distance below the neutral axis. Okay, that is given here. That distance specified here above or below. Okay, 25 that distance is below the neutral axis. Means we have to calculate how much shear stresses induced at a distance 50 mm above neutral axis and at a distance 25 mm below the neutral axis. Means that is we have to calculate Q50 and Q25. Okay, how to calculate Q50 and Q25? In the same manner we can calculate here in this problem. We can use only one formula, that is Q distance, that is equal to 6F upon BD cube into in bracket D square upon 4 minus 5 square. Okay, that formula is only applicable for this problem. Okay, here whatever data you have provided, you just write that data according to whatever information we have to give it in the problem. Okay, and according to that information here, first information, the section is rectangular having width and depth. Okay. This is the rectangular section. This is a width. Is represented by that is divided 100 mm, 100 by this is the depth. Depth is given 200 mm. This is a neutral axis or neutral layer. That distance is given above 50 mm. That distance is 1, and below 25 mm. That is represented by, okay, below and above distance from the neutral layer is provided, and we have to calculate shear stresses induced on that layer above neutral axis, that is 50 mm, and below the neutral axis, that is 25 mm. Here in this problem we have to calculate a rectangular section, rectangular section having width b is equal to 100, depth b is equal to 200. Okay, then shear force, shear force F is equal to 60 kilonewton, then 60 into 10 raised to 3 Newton. Okay. Then other data is to find Q50 and Q25. Here in this problem, we have to calculate Q50 and Q25. Very simple way to calculate Q50 and Q25. The procedure will be same as in see the previous problem we already see. Here, distance is represented here. If you consider y1, if you consider y2. About neutral axis distance, for our sake of convenience, you just consider y1, that is 50 mm. Then y2, that is 25 mm below the neutral axis. Okay, consider y1, y2 for our sake of convenience. You can easily calculate that value. You can easily put that value in the formula. Okay, and for our sake of convenience, you just consider y1 that distance above the neutral axis 50 mm and y2 that distance below the neutral axis, that is 25 mm. Okay, that is just give that notation y1 y2 for the sake of convenience. Okay, then here to find Q50 Q25, then first thing we have to calculate or to find out shear stress at a distance y1 that is 50 mm from neutral axis. 50 mm from neutral axis. Okay, that distance is considered here. Here in this problem, Q50 formula will be same. Q50 that is equal to 6F upon BD B square upon 4 minus y square. Y whole square. Okay. Then we just put up the value. What is the value of F? 60 into 10 raised to 3. B is given 100 into 200 cube. B is given 200 square upon 4 minus y1 is 50 square. Okay. Then here we just calculate the value is 3.375 Newton per mm square. Q50, that is the final value we get Q50. Okay, that is very simple way. Only one formula is applicable here. 6F upon BD cube in bracket D square upon 4 minus y1 square or y square. Here you just give the name 1 and 2 y1 and y2 because there are two distances here at 50 mm above neutral layer and 25 mm below the neutral layer. Okay, and that's why that is considered y1 and y2 for our sake of convenience only. Then here first we calculate shear stress at a distance 50 mm from neutral layer or neutral axis. Now the formula will be same. Q distance that is 50 is given, y is distance is given. That is equal to 6F upon BD cube into bracket D square upon 4 minus y1 square. We just put up the value and we calculate value of Q50. Okay. In the same manner, the shear stress will be induced on that layer at a distance 25 below the neutral layer. That is represented y2, that is 25 distance. Here, the procedure will be same. Shear stress at a distance y2 25 mm from neutral axis. Shear stress at a distance y1 here above at a distance at a distance from neutral layer. Then here we just apply the same formula 6s upon BD b square upon 4 minus y2 square. Here 6 into 60 into 10 raised to 3 divided by b is given here. This is b is 100 into 200 to b is given 200 square upon 4 minus y2 is here 25 square. You just calculate the value, then final value we get. That value will be 4.2 4.218 Newton per mm square. Okay, that is the value. This is a very simple way to calculate the known values of Q25. Okay, this is a very simple way to calculate that value. Means in this problem, we have to calculate. We need to calculate how much shear stress is induced at a particular distance. Here that distance is given 50 mm above the neutral layer and at a distance 25 below the neutral layer. That is our aim. We have to, we need to achieve that aim. The procedure will be same. Here, rectangular section is given having width is represented by B 100 mm and D 200 mm. Okay, means rectangular cross sectional 100 by 200 mm that will be provided in the problem. Here, one thing is also given. Shear force is given. It is represented by F. 60 kilonewton means 60 into 10 raised to 3 newton. Then to find out Q50 and Q25. Okay, what is meaning of Q50 and Q25? Means how much shear stress is induced on the layer at a distance 50 mm above the neutral axis and 25 mm below the neutral axis. Okay, that is the meaning of that particular Q50 and Q25 according to data provided in the problem. Okay, then first we find out the shear stress at a distance y1 that is 50 mm from neutral layer. Means that 50 mm distance always consider above the neutral axis. The formula will be same. Q50 that is equal to 6 F upon BD to be bracket D square upon 4 minus Y1 square. Okay. Then we just put up the value of BDF Y1. Then you can easily calculate the unknown values of shear stress at a distance 50 mm above the neutral layer. Q50, okay, in Newton per mm square. In the same manner, we calculate shear stress at a distance 25 mm below the neutral layer. The formula will be same. Q25 that is equal to 6 F upon V2 in bracket E square upon 4 minus Y2 square. Okay, Y1 and Y2 because there are two different distances given. That is above neutral layer 50 mm is given and below neutral layer is 25 mm is given, and that's why we here just consider y1 and y2 for our sake of convenience. You can easily get or you can easily understand distance. Okay, which distance we have to apply in the problem in the formula. Then here 225. Then we just calculate by putting the values of P, D, F, and y2. Okay, you can easily calculate. Then the final value is Q25, that is shear stress induced in the gradient section, means additional 25 below the neutral layer. Q25 is 4.218 Newton per mm square. Okay, in this way you can easily calculate how much shear stress is induced on the layer at a distance 25 mm and 50 mm from the neutral layer. Okay, it is very easy way to calculate. Then one thing is also remaining. That is how to look like shear stress distribution diagram according to the rectangular section. The diagram will be same in videos like this. This is the diagram. This is the shear stress distribution diagram. Neutral layer, Q max and Q0, Q0. Okay, that here we have to calculate distance. The distance that is Q50 and Q25. Okay, that value we already calculated 3.375 Newton per mm square, and here 4.218 Newton per mm square. Okay. That is stress distribution, shear stress distribution diagram. Shear stress distribution diagram is a very simple way. You can easily calculate that value, as well as you can easily draw the shear stress distribution diagram. Okay, here in this diagram, at the top extreme layer of the rectangular section beam, the shear stress induced will be equal to 0. In the same manner, at the bottom extreme layer of the section beam, that shear stress induced will also be 0. But the maximum stress will be induced or generated at the neutral layer, here Q max. Then here